Good evening, everybody. Welcome. So tonight we're going to talk about submarine gold. What the heck is that, Jess? Well, I just thought it's time for another way out there topic. So tonight we're going to talk about gold and submarine canyons, and gold and longshore drift, and gold and oceanic processes that lead to gold being elsewhere. We'll talk about how much and kind of what kind of gold this is I'm talking about. And it's intriguing in several aspects. One is that there's an increasing interest in offshore gold and nearshore gold, as seen on TV, Bering Strait and all that kind of stuff. So, but you've seen it as well as seeing, Bering Sea gold. You've seen gold in other places. You probably didn't hear about it in Africa and so forth. But this is something that's kind of interest to me. But what you may not know is that gold goes somewhere. Okay, it came from somewhere, it goes somewhere. It's kind of a cycle. We'll talk about that tonight. So how are you doing? How's everybody going? I'm checking in on you to see if we got our audio and everything going well. Looks like so far we're going good. Audio and video good here. Australia, good thing. Sound is good, picture is good, says Charles. All right. South Carolina checking in. Hit those rivers and stand. Be glad when this weather gets warmer. Yeah, I know everybody's getting frozen. Gee, frozen. Except where they're not. Good day in Perth. Hope you're all well. Well, I think we're all doing fine. We've got a couple of issues going on here, typical family kind of things, so we're working those out. Hang on one second here. Allergies being one of them. I got allergy season on board. You see, with all of that cold weather in the Midwest, we've been getting a lot of these east wind conditions here. And when that happens on the west coast here in the U.S., it tends to blow all manner of pollens from unique and the usual places. And so what ends up happening is I'm allergic to anything, you name it. In fact, a lot of those imported products from Australia are some of the worst ones. I am really allergic to eucalyptus or eucalyptus derivatives. And so all those plants with fancy bottle brushes and things like that tend to just send me flying about this season. Just the way it is. So I hope you guys have a better pollen season than I'm having. Let's see. So where were we? We were going to talk about submarine gold. But to start this off, I wanted to kind of tease you a little bit. Where does gold come from? Well, okay, it comes from a lot of places. And here's the deal. Some of it's been recycled. Some of it's kind of like green gold. That is, it's been through the loop a couple of times, and so it's a little hard to determine exactly where that gold came from, in the sense that it's once gold gets worn out of load in the bedrock, once it comes up and is concentrated in secondary hydrothermal deposits and things like that, it enters the stream. And when it enters the stream, it's like one great big grinder. It just grinds off little tiny particles of gold everywhere, and some big particles. But the smallest ones, including some that actually go into solution, how about that? Thanks to chlorides, sodium chloride being the main one, the gold will precipitate, or rather descend, toward the ocean. That's the direction all water flows to the ocean. So when the water flows to the ocean, it carries with it a bed load. That bed load carries with it a load of gold, and so a fair amount of gold, in fact. And so the question you might ask is, well, where does that go? And I'm going to talk a little bit about that tonight. I'm going to introduce you to a couple of new topics, so get ready for learning curve. They're not going to be too hard, though. It's just interesting stuff. And next time you look at a satellite picture of the ocean, or you get up in a hotel nearby an ocean, you're going to be changed. I guarantee it. Okay? You're going to see the ocean differently. So here's the deal. Yep, and everybody's logged in and going. So we're going to continue down this road. The deal is that we have a concept when we have the gold flowing out of the mountains toward the ocean. Let me go to the chalkboard. So as our gold erodes, let's start off with our mountains being green. People like to paint mountains as green, so we're going to make mountains are going to be green. And as it goes down toward the ocean, everything turns blue. So we'll make the ocean blue. Columbus sailed the ocean blue, all that stuff. So now, in addition to that, we're going to have some rocks and mineral outcrops. So we have some stuff that kind of comes up out of nowhere here and pops out and outcrops. And inside that outcrop, we're going to plant some gold, just for grins. Snappy stuff. So I'll just make it kind of gold looking like that. Now, as this stuff goes and gets worn out of this and bounces down the mountain in the riverbed, the gold will eventually make its way to the sea, but before it gets there, it's ground pretty fine, most of it. And so what happens here is, as the gold enters the sea, it collects in the ocean here near shore, because remember, gold is dense, so it's going to stay near shore, with one notable exception, actually a couple of them. One is superfine particle gold can kind of float under almost any motion of water, so it can actually float along on the ocean itself. But we're not talking about that in this particular case. There is also another form of gold, which is gold in solution, actually gold salts, gold chlorides specifically, and they can kind of go every which way. But what's going to happen here is, as things accrete on the layers of the near shore, so there'll be kind of this sand and silt and whatnot forming on this inshore area here. And as those things kind of spread out in the ocean, they will tend to deplete toward the edge here of the crustal area. And so what happens is that forms layers and layers and layers of sand. Okay, now that sand can do two things. One, it can just get so many layers that it compacts itself in situ. It just compresses down on top of itself. That takes a lot of silt, but there are places in the world that have a lot of silt, especially large river systems. Mississippi comes to mind, and so forth. But what we're going to show you here is something a little different. If it doesn't stay put, then it's going to start moving. And when silt and sand start moving, it carries the gold with it, just like it would in the ocean, in the river water. The sand and silt forms a river, nearshore river. Did you know that? Okay, so we're going to talk a little bit of how that happens. How does that come to be? Because the big question here is, where's the gold? Where is this gold going to go? And what are the following, what are the processes that follow this thing down shore, down to where it's going to go? Because, of course, we want to know, where does gold concentrate? That's why we're here on Hunting for Gold and sourdoughminer.com. You can check those things out. But we're here to help you find more gold by giving you articles and things like that that show this kind of stuff. So now, let's go look at this thing. So we've kind of gotten a side view here. The mountain range, the gold moves down, gets ground to a pulp, and then deposits near shore. Now, what I'm going to show you next is kind of something you may or may not know about, but it's kind of a fun little novel thing. It was part of what brought me to thinking about tonight. And this is a concept called longshore drift. You ever heard of it before? Comment if you had. So longshore drift, well, longshore drift is a really unusual process that takes place along any shoreline, okay, that has waves. That's the key feature. Now, with those waves goes deposits that might form surrounding those waves. Now, sometimes the deposits are zero. It's just rock and bedrock and more bedrock. Maybe some seaweed or clams or some kind of zoological thing stuck to the rocks, but not much else. Okay, we're not talking so much about that as places near rivers that have lots of sand entering the ocean. Those rivers supply a river of sand. That sand is moved along the shoreline by a thing called the longshore drift. And what causes it is, the wave action. So you can see right here we have a series of waves. I'm drawing red lines on their lines to indicate these waves. And the waves are approaching the shore not at what we call normal. They're not approaching the shore directly. They're approaching at an angle. And the angle's ever so slight, but if you look from a hotel or if you look from standing up way up on the beach on a bluff and look out, you can see that waves don't strike the shore. That's why surfers always surf at an angle. They surf along the shoreline. If they surfed quickly to shore, they'd be over in a matter of seconds. But instead, they can surf along the wave as it enters this longshore region. And they can go on and on and on for, seconds, tens of seconds, sometimes maybe even a minute, depending upon how long this thing goes. Okay? And that's what we're looking at. Because that longshore action, those waves closing in on the shore at an angle where the wave basically, kind of collapses along the shoreline, but only at one point at any given time. So it's kind of like it's intercepting the shore and disappears. I'm not doing that right with my hands, but you get the idea. It's coming into shore and then disappearing as it collapses on the shoreline. Well, that squeezes the water down along the shore, along this longshore tangent here, going parallel to the shoreline. This is one of the things that causes, of all things, rip currents, okay? Or what used to be called a rip tide. It's not a tide at all, it's current. But it's current from the buildup of the water in this longshore current. Now, you go, well, how can there be very much water? There's a lot of water moving here. Remember, it's the whole ocean surface along this coastal region that's in motion. And so what's happening is there's a lot of water at any given time that's moving. It's not moving super fast, but it's moving steadily. Now, if you got something like, this were a tsunami, it'd be moving fairly fast and fairly high volume, and it would build up. We're not talking about that either. We're just talking about ordinary wave action along the shoreline causes this stuff to build up and then essentially have to escape. I'm going to draw it in green here. So this thing has to escape down shore, and at some point it builds up so much material in terms of mass of water that it'll actually escape via a route perpendicular. It'll go right out under the waves, and that's where you get your rip currents. Okay, now here's the deal. Most of that rip section is very narrow but very swift, so it shoots right out to sea in a hurry, and guess what? You're never going to win against this. Okay, you just can't win swimming against it. But if you swim perpendicular to that current, you swim across it, which means you're swimming up and down the shoreline, take your pick, you can escape the current. Why? Because essentially you're going to run out of it much quicker than you'll run out of it by trying to fight against it. You basically go out of the current, and then you can swim up and onto shore away from where the rip current is diving out to sea. Now we're going to talk a little bit about what that diving action does, because it's really important, especially near submarine canyons. Hence the submarine in tonight's topic. So this waving action, the longshore thing, forms these pockets, these currents that flow every which way apparently, but they really don't. They have a very steady kind of force, and in some cases they have a very fixed position. Case in point, just south of me here, about 2 miles, is a canyon, a steep canyon that goes out into the deep plain, if you will, offshore. And that canyon takes these currents of sands and routes them out offshore, into the deep sea, where they cease to move much. They just continue to build up and spread out. There's sort of this steady spreading and layering. As that happens, layer upon layer upon layer, you kind of get a feeling for what's going to happen. When you put layer upon layer of concrete on top of concrete, what's going to happen to the stuff on the bottom, especially when it's in an environment that has high calcium and chlorides and other chemicals and maybe sulfides and who knows what, okay? It's going to start reacting, and it's going to start bonding together, and it forms new rocks. Now, some of those rocks are very simple. Simple calcified sand is called sandstone. Whoa, hey, but that sandstone, remember we talked about gold? It can contain gold, okay? If we take that thing further and have it get submerged deep enough that it gets really highly compressed and maybe a little heating, or it gets taken back under the continental crust, and we'll talk about that in a minute, okay? It can create metamorphic rocks, such as slates, schists, gneiss, that whole thing. We've talked about those in the past because that's one source of gold. Ever wonder where that metamorphic stuff got its gold? It's right here, okay? So submarine gold is all about where that stuff came from. And so what we're going to talk about a little bit more is how all this fits together. So let's clear the whiteboard here. I'm going to scroll down here a little bit. But the beach sand is moved by such oblique wind days and the swash and backwash of water on the beach. That breaking surf kind of moves things at an oblique angle, and the gravity and the water draining because it builds up, then it has to drain, like I said, out to sea. It has to build up a balance, or it's going to stack up forever in the shoreline. It can't do that. It gets to a certain point where enough potential energy is built up from the altitude of the extra water being pressed down the shoreline that it has to escape back out to sea to set equilibrium. So this is a beach drift, okay? And there's an argument whether it's longshore beach drift, but it's all part of the same situation. This wave action puts energy along the shore, and that energy is strong enough to move rock in the form of sand, okay? And if that sand is moving hard enough, it can actually move pebbles and cobbles and things like that. That's why you notice at the outlet of a river, you'll have cobbles and stuff. Well, those cobbles show up way down shore. How did that get there? Same action. It's just over years and years of waves and these drifting actions. It moves more than just sand. It can move anything along that shoreline and actually sand it and grind it even more. But if there's gold in that material, there's gold moving down the shoreline. And there are some shorelines that are really good and really loaded with fine gold in the sands on the shore. Telltale for that, by the way, is black sands in your pans. Okay, so if you see a fair amount of black sands in your pans or layers of black sands in the shoreline cut, you're in an area that likely has stuff that came from some material that contained metallic ores in the past. Most of that black sand material is really ultra-fine forms of this stuff, which is magnetite. But as we've talked about in the past, the magnetite itself can come along with gold. Also, a lot of the rocks and minerals that are around the magnetite have gold. Serpentine has magnetite in it, and it also has platinum, so there could be platinum in your offshore thing. Not so likely silver, because silver tends to deteriorate in solution, and it has different chemical processes. It is not inert like gold is. Gold and platinum, they stick around. They get ground finer and finer and finer, but they stick around until maybe at the finest level they might interact with chlorides, as I said, in the case of gold, to form gold chlorides in the water. But that's a really, there's a lot of it, but it's really hard to remove from the water. So a whole nother story. It is. Then there'll be down the longshore current edge of things will be where the sands will carry the gold. And you can find the gold sometimes, and sometimes there's access given. You can actually mine it using different techniques like high banking and stuff like that, panning. Last time I checked, there weren't too many places that would ban you for panning because they would have to ban kids with their sand buckets. You could just use a scooper, a little trowel like kids do. And anyway, I'll let you go with that one. What a visual. So how about submarine gold? Good night and good prospecting, guys. Like I said, don't forget to check out that GGM. See you then. Catch you later. Bye-bye.